Welcome to Neo Nexus. Today, we're about to embark on a journey to one of the most extraordinary places on Earth. A place where the ground itself seems alive with energy and mystery. Don't forget to subscribe and hit the bell icon so you never miss out on our explorations of the planet's most fascinating wonders. Deep in North America lies Yellowstone National Park, a land of erupting geysers, vibrant hot springs, and herds of bison roaming across vast meadows. It's a place where nature's power and beauty are on full display, drawing millions of visitors each year. But beneath this breathtaking landscape, a colossal force is at work. Yellowstone sits atop one of the world's largest and most active supervolcanoes, a hidden giant that has shaped the land for millions of years. Unlike typical volcanoes with a single peak, Yellowstone supervolcano is a vast underground chamber filled with molten rock. This immense reservoir of magma has fueled some of the most powerful eruptions in Earth's history, leaving behind a legacy of dramatic geological features. The intense heat from this hidden chamber powers Yellowstone's world-famous geysers, bubbling hot springs, and steaming fumaroles, creating a landscape that is constantly shifting and evolving. Scientists from around the globe are drawn here, setting up sensitive instruments to monitor every tremor, every subtle shift in temperature, and every sign of volcanic activity. Their work is crucial for understanding the restless nature of this giant beneath our feet. Yellowstone is more than just a national park, it's a living laboratory, offering rare insights into the dynamic processes that shape our planet's surface and drive its ongoing evolution. The rocks, mineral deposits, and thermal features here tell stories of ancient eruptions, ongoing geological activity, and the powerful forces that continue to mold the landscape. By studying Yellowstone's ever-changing environment, scientists gain valuable knowledge about volcanic systems, not just here, but all around the world, helping us prepare for the future. This park is more than a scenic wonder, it's a window into Earth's ever-changing nature, reminding us of the incredible power and beauty that lies just beneath the surface. Recent discoveries show Yellowstone's ground is undergoing a fascinating transformation. The ground is slowly being pulled apart, a process that is both subtle and profound. The eastern side shifts east, while the western side moves west, creating a subtle but measurable split that scientists are closely monitoring. GPS technology reveals that the land is separating by a few millimeters each year, tiny but significant over time. This data is crucial for understanding the park's geological future. This slow stretching can eventually reshape entire landscapes, altering the park's topography in ways we are only beginning to understand. The most pronounced splitting runs north to south, near the Norris Geyser Basin, one of the park's hottest and most dynamic areas. Here, the crust thins, letting heat and magma rise closer to the surface, fueling the park's famous geysers and hot springs. Scientists once focused primarily on the Caldera's vertical breathing, but now recognize this horizontal stretching as equally important in understanding Yellowstone's geology. Yellowstone isn't just rising and falling, it's stretching too. This dual motion is a key to unlocking the park's geological secrets. This dual motion reveals a complex dynamic system beneath the park, one that is constantly evolving and reshaping the landscape. The ground's movement is a silent testament to the immense forces shaping Yellowstone, forces that continue to intrigue and challenge scientists. To truly understand why Yellowstone is splitting, we need to take a closer look at the continent's deep structure and the powerful forces at work beneath our feet. The story begins with the land itself, vast, ancient, and always in motion. Yellowstone sits within the Basin and Range Province, a region where the Earth's crust is being stretched and thinned over millions of years. This stretching creates a landscape marked by long valleys and rugged mountain ranges, evidence of the crust being pulled apart. Tectonic plates, especially the Pacific and North American, are in constant motion, generating immense stress along their boundaries. These plates push, pull, and grind against each other, slowly tearing the land apart and creating fault lines that run for hundreds of miles. Imagine slowly pulling a piece of clay until it thins and finally cracks. That's a simple way to picture what's happening deep beneath Yellowstone. The Earth's crust is under tension, gradually being pulled in opposite directions. Adding to this, the Yellowstone hotspot, a plume of superheated mantle material, rises from deep within the Earth, further weakening the crust from below. This hotspot acts like a blowtorch, softening and thinning the crust, making it even more susceptible to splitting. The combination of regional stretching and intense local heating makes Yellowstone a unique focal point for dramatic geological change. Here, the forces of the planet come together in a way rarely seen elsewhere. Over millions of years, the hotspot has left behind a trail of ancient calderas, massive volcanic craters, across the landscape, each one a testament to the incredible power and persistence of these forces. The crust here is more pliable and flexible than in many other places, making it easier for it to split and shift as these forces act upon it. Importantly, this ongoing splitting isn't a sign of an imminent eruption. Instead, it's a natural and essential part of the continent's slow, ongoing evolution, a process that has shaped North America for millions of years and will continue far into the future. Yellowstone's movement is just one part of a grand tectonic dance, a slow, powerful choreography that has built mountains, opened valleys, and created the landforms we see today. The ground splits because it's caught between powerful forces above and below, a vivid reminder that our planet is alive, dynamic, and always changing. Yellowstone's splitting isn't unique. Earth's surface is always in motion. The East African Rift Valley is a dramatic example, where a continent is slowly tearing in two. Iceland too sits atop a rift, with volcanoes and fissures marking the divide between tectonic plates. Yellowstone's rifting is smaller but driven by a unique mix of forces, regional stretching, and a powerful hotspot. Unlike oceanic hotspots like Iceland, Yellowstone's sits beneath thick continental crust leading to explosive supervolcanoes. This rare combination makes Yellowstone a complex system, both volcanic and tectonic. The rifting here isn't just forming a valley, it's interacting with one of the world's largest volcanic systems. Studying Yellowstone helps us understand geological hazards worldwide. Its unique geology offers insights into how continents break apart and how supervolcanoes form. Yellowstone is a global key to understanding Earth's restless crust. Scientists use advanced tools and innovative technology to monitor Yellowstone's constantly shifting ground. High-precision GPS stations detect ground movements as small as a fraction of a millimeter, providing vital data. INSAR satellites create detailed maps of ground deformation, revealing patterns of stretching and sinking over time. Seismometers record thousands of small earthquakes each year, mapping the movement of magma and water deep below. The Yellowstone Volcano Observatory combines data from GPS, satellites, and seismometers for real-time analysis and rapid response. They also monitor gas emissions and water temperatures, searching for early signs of new volcanic activity. This network acts as an early warning system, tracking every subtle change in Yellowstone's environment. The data helps scientists better understand the park's complex underground plumbing and its behavior. Continuous monitoring is crucial for public safety, early warning, and ongoing scientific discovery. Thanks to these efforts, we have a much clearer picture of Yellowstone's dynamic and ever-changing behavior. Yellowstone's slow stretching hints at its future. Over thousands of years, the rift could deepen, forming new valleys and changing the landscape. Faults may become more active, causing small earthquakes along the splitting zone. The hydrothermal system will evolve as new cracks allow heat and water to reach the surface. Geysers and hot springs may shift or new ones may appear, especially in active areas like Norris Geyser Basin. The park's plumbing will keep rearranging itself as the ground moves. Despite the dramatic changes, scientists say a catastrophic eruption is extremely unlikely. The current movement is slow and steady, not a sign of imminent disaster. Yellowstone's future is one of gradual transformation, not sudden catastrophe. The park will remain a place of wonder, where Earth's powerful forces are on display. Yellowstone's splitting ground reveals the park's true significance. It's not just a volcano, it's a living example of a continent being reshaped by deep forces. The interplay of tectonic stretching and hotspot activity makes it a unique natural laboratory. Continuous monitoring helps scientists understand not only Yellowstone, but similar processes worldwide. The data gathered here informs geology, seismology, and volcanology across the globe. Yellowstone's story is one of constant change, reminding us that the ground beneath us is alive. Its beauty lies in both its landscapes and its raw geological energy. The park inspires awe and curiosity, challenging us to keep learning about our planet. The splitting ground is a call to explore, not to fear. Yellowstone stands as a testament to Earth's enduring power and endless transformation.